Testing. Alright, Chapter 2, Introduction PCB Design Flow by Example. Now you have covered the construction of PCB, now with the layout, know the layout's role in it. We will go through the simple design example so that you get a feel overview design process. For the simple example that sets at stage of our Chapter 3, which will dig deeper into the details of the process, learn more about the layout itself. Chapter 9, in which PCB boards design examples are presented. Overview of the design flow. The section illustrates the basic procedure for generating a schematic capture for the converting of the schematic to the board design and layout. The basic procedure is follows: start capture and set up the PCB project using a PC board wizard, making a circuit schematic using Orcad capture. Using the capture to generate the layout netlist. Save the M as an MNL file for layout when selected the PCB technology template or TCH file. Save the layout project as an MAX file. Layout of the import of the MNL and that list and into the MAX file. Make a board outline. Position the parts of the board outline. Auto route the board. Run the post processor to generate the files used to manufacture the PCB. Alright, creating a circuit design with the capture. If you don't have the full version of Orcad, you can install the version 10.5 demo CD included with the book, or go to the Orcad website, download the latest for demo. If you're using older version layout, you may have the following information in this book still applies, but some of the dialog boxes menu items may be different. Starting a new project before you make the PCB layout, you need to have the circuit to lay out. You will use this capture to make a schematic. First step is to start a capture application by clicking Windows Start button on the taskbar and navigating all programs. Orcad 10.5 demo. Once the capture is running, you should have the blank capture session frame and a session log. Go to File drop-down menu, File New, and click Project as shown in Figure 2.1. The new project dialog box shown in 2.2, it will pop up with the type of the name of the project. Select with the PCB wizard radio button. If you're comfortable with selecting your own location, save with the project, you can do this. Do that, you can use the default location just so to remember where you'll need to find it later on the layout. Click OK. After you click OK, the PCB project wizard dialog box shown in Figure 2.3a will pop up with now circuit simulation will not be circuit simulation will not be performed, so we'll leave enable project simulation box unchecked, and we'll take a look at the circuit simulation chapter 9. Check the next. After the next, PCB project word dialog box shown in Figure 2.3b will pop up the dialog box, and the box allows you the specific libraries to your project. Scroll down until you find the discrete OLB library. Highlight with clicking on it, and then click Add button to the finish, and then complete the project setup. You should have the project manager window left side of the capture screen session frame as shown in Figure 2.4. You may also have the schematic window for in the workplace. The schematic is not open. Expand with the project name DSN directory with the clicking of the positive button plus box, and that the left of the project name DCN icon, which project name is the name you give the project. While using the project setup wizard, click the plus box next to the schematic folders and Figure 2.2 shows the new project dialog box name. Create the new project analog mixed AD PC board wizard problems logic wizard schematic, and you got those 4 wizards, and you can put PC wizard in your location browser and OK. Then we move on to Figure 2.3a simulation section. You can skip that, and then B parts B section, and you're going to add those libraries. Double click the file with the page 1 schematic page shown and open it. If you don't see what the dots mean, if the grid is turned off, the grid must be turned on properly. For the parts, turn the grid on, click the button with the grid button with the arrow marker in it. If the grid is on, the grid dots will be visible. Grid button will be gray instead of red. Now you have your example of the view of the new project. You have your library open here, you have your tools, you have your scale, you have your ribbons, and your open schematic with the dotted view, which was trying to note. Or the menu at the top of the capture screen session frame depends on whether they're working with a project window or the schematic page window. If you need to access the option tool of the project manager schematic page, you need to have that window active. To make the desired window active, click on the title bar, select the desired window of the window menu. When it is inactive, it will be gray. When it's active, it will be blue. Whatever colors you have set up in the Windows. Also projects that have PSpice simulation capabilities. There is an additional toolbar plated not shown in Figure 2.4. Placing the parts. To add parts of the schematic, make the schematic page active. Select place from the part drop down menu. Press the place part with the tool button, which shows the little inverter, or press P on the Connect keyboard for place. Place part dialog box shown in Figure 2.5 pops up. The library selection box in the bottom of the left dialog box called discrete. Click discrete. Then the part list over the box will click C for capacitor. You should see a symbol preview window in the lower right. Click OK into the libraries. Windows, you have library window in the library windows. You may have the libraries different from the shown Figure 2.5. At very least, you should have the discrete library, since you have the window wizard included in it. If you have some reason don't see any of the parts in the discrete library not here, you can follow along now to get an overview of the process. You can find and add the library to your project. Alright, to add a library add a part to the library. To your project, select place from the part drop-down menu described above. In the place part dialog shown in Figure 2.5, add library button to the bring of the browse file with the dialog box shown in Figure 2.6. Find and select with the discrete library OLB library. Click open. You can find the capacitor in the PSpice library folder. To add, double click the PSpice folder and select the analog OLB library. Click open. You should now be able to back at the place part and dialog box library just added shown in the library list box. Find the select C for the part list selection over the box. Click OK. So here's the part C and all its capacitor value, symbol, view, part, graphic, parts per packaging, libraries, part, and abbreviations. And after you click OK, you should immediately return to the schematic page. Have the capacitor tagging along with you. The mouse pointers. Left click the schematic over the place part with the shown Figure 2.7. Place a couple of capacitors on the page. When you're finished, hit the escape key with the right click of the mouse and end mode for the pop-up menu. So now you've had this 2.6 of adding a library to browse file with the dialog. We're in the browse file with the dialog, and then you're adding your capacitor files to the placing the parts on your schematic. Wiring, connecting the parts. Next to connecting the parts of the wires, to place the wires, hit the W key to select the place, or select place wires, or place for the drop-down menu. Press place wire toolbar button, which looks like a little zigzag, but it's not a Z. The cursor will turn into the crosshair of the place for the cursor box on one of the capacitor leads and left. The click of the start wire. Click on the end of the capacitor to leave the complete with the wire crosshair with a little persist for the continuing placing wires. For instance, connecting wires to the capacitors however you wish. Once you finish connecting the circuit, press the escape key, right click, select end wire to stop the place of the wire cursor. Get the pointer back and inadvertently click near the light lead, not on it, and the wire appear to be connected but may not be. This is why it's important to have the grid enabled. If the connections are not made properly, you will have the problems attempting to generate the net list. You will be able to tell if the connection made with the component would completed properly because of the box. If the end of the lead will disappear at the point, don't worry about the power supply and ground connection. This is just a big picture exercise to demonstrate the design flow process. So 2.8, placing wires, that's done with a W or a place part command, or the wire button. Creating a layout net list capture. One of the connection complete with the next step of the create of the net list. And ASC2, the text file will describe the structure with several types of net lists, but you will be able to generate with the layout net list. If you make it with the project member, the window active instead of the schematic page window. Select with the DSN icon, left in, clicking it once the schematic page is active. The tools menu will not be available. Minimize the schematic page if necessary to get to the project manager. Is shown Figure 2.9. Tools, create net list from the tools menu. Create net list dialog box will appear. Show Figure 210. Show the so now we went to the top ribbon. We went to tools and creating a net list. Figure 2.9. With the net list open, we see EDFI and F layout, and that's where we're headed right now. PSpice, Verilog, VHDL, and other. So far in the layout, we have a PCB footprint combined properly stringed. Options RE echo to layout properties inches or millimeters. A net file list browse, and OK and cancel. From the Create Netlist dialog box, select the Layout tab later, as we were in. Later, you will see how to set up the file structures to organize your project. For now, just save the current default directory. Remember when where netlist file with the MNL extension is saved. Leave the running eco to layout radio button unchecked for now. Use the eco engineering changing order tool, chapter 9. Click finish to generate the netlist. Capture the display warning text box starting in the design path. Your name, DSN. Will be saved prior to netlisting. Click OK. Capture the generated netlist. Report with the results. The session log. At this point, you will have the generated netlist with an MNL extension that layout can use. You could close the capture now, but leave it open so that the capture and the layout can communicate with each other if necessary. This will allow you to go back and review the circuit if you need when you are working in the layout. Designing PCB with a layout, starting layout, importing netlist. Now you will use the netlist in the route of the board using a layout. Begin with a click of the Windows Start button, taskbar, all programs, Orcad demo. Once layout is up and running, will be presented with a black session frame. Initially, begin working with the board. You need to layout. Tell the layout the kind of the board you want to use. The import of the netlist generated with the capture into the board type. Begin selecting with the new from the sessions frame. File menu, auto, eco, automatic engineering changing order. Dialog box will pop up showing figure 211. There are 3 pieces of information that you need. Figure 211 shows the assigning a per PCB technology file. We've now went into the layout max file, and we've went to the data file, and we've opened up auto, eco, and it's browse. You need to enter the auto eco, add the first 2 pieces of information, the TCH MNL text box, label the default value, third max text box. First step, select the board technology, select the board technology template or a wildcard TCH file. Click the browse button across the TCH text box and navigate the tool's layout data folder. The layout should go automatically show the default technology template default. TCA technology template as shown in figure 211 will summon the order files or technology files chapter 9. Click open the wizard and type the path the name of the technology file into the text box for you. Once the technology file is assigned, you need to select the layout netlist, the MNL file you generated. To do so, click the browse button across the netlist text box. Locate the netlist file created with the capture. You probably won't see it. You will not see it at first, since you're likely to be in data folder, for which you select the technology file. Navigate to whether you save the project, where you save the project. Once you find the file, select it and click open. The wizard will type the file and type the path with the name of the netlist into the text box for you. Figure 212, opening the netlist. Once you've entered within 2 pieces of the information, the wizard will file the max file with information for the default name of the figure 213 max file. The layout project contained with the information needed to build your board. You can use the default name and recommended for the now. Save with a different name. Click the apply eco button at the bottom of the dialog box. You don't need to make any changes to the option settings at this point. Layout will immediately go about the project environment. So now we're in auto eco. You've got an input TCH and max file of the net listing and output max file, which it will become. When setting up the project layout, checklist footprints assigned with each of the part. Netlist footprint assigned with the footprint with the layout does not need to be assigned with the part. Layout will ask the choose of the footprint with link the footprint of the component dialog shown in figure 214. Most likely this will be the case since no footprints were assigned. These parts are captured. You'll see how to do this in chapter 3 and 9. If you get the link footprint dialog box, click on the link existing footprint to the component button. So this is the auto eco link footprint component dialog box. Can't find footprint component capacitor 2 part name C place choose the one option below. Link existing footprint to component, create and modify footprint library, defer remaining edits until completion. Layout will initiate footprint library utility figure 215 depending on how and if the layout has been used. You may have the libraries different as shown in the figure. If you're using the demo version, you should have at the very least have the EX underscore guide library, which you should select. The E footprint should be the footprint box should be below the library box. Find the SIPTTML 200-2 footprint. If you use the full version, select the TMX underscore axle LLB. Select the footprint has two pads. The picture of the footprint to play for the preview window. On the right of the dialog box, Chapter 8 will see how the add the other libraries footprints to show that have to make a home footprints. If you have one need does not exist, for now click OK. Once you've selected the footprint layout, will assign the footprint to all the capacitors in the design of the default. If you have the other components addition with the capacitors, you will probably have to repeat the procedure for each time the type of the component. Right now, it's not important that what footprint is because we just wanted to get the overview of the overall process. So now we're looking at the footprint of our libraries and our footprints and the utility. Once the auto eco utility complete with the assignment of the footprints of the you should end up in the board layout with the environment shown figure 216. The design window from the board for your board. You can see the component footprints as well as the silk screen assembly details as visible over the board origin. Board drill symbol table. We'll look at these items in greater detail, but right now we'll concentrate on making a board outline, placing the parts, and routing the traces. So here is what you see in the layout initial view. You see your origin drill chart, component footprint, your rat nest, and outline DRC route box. Note that the window taskbar, there are two layout applications for the initial one with the layout session frame with the other design window that was just open. To get a better view of what you're trying to work on, you may want to zoom in and out, move the view up and down to the left or the right. Zoom out with the cursor location you would like with the center view would be hit the letter O on the keyboard to zoom in, play with the cursor location center view with hit the letter L. Hit the letter I on the keyboard to resample the view with zooming in and out with the place for the cursor of the design channel with the letter C. If figure 217 shows some of the other viewing feature that you can use the view drop down menu. If you get the view that it cannot get out of and you want to get back to the layout workspace, select the design option on the view drop down menu. You can also hit zoom all button or hit the shift plus home keyboard to see the whole board. Making a board outline. Next, we'll add the board outline. A good practice of the place for the board, lower left-hand corner of the origin that you will have already done with a zoom out, so you can see the entire drill table having located near the bottom of the window. And I'll make sure the only online design rule checker DRC box is off. If you don't see it, if it's already off, but if you see the dash or solid white boxes in the workspace, the design rule checkbox is on. To turn off the design rule checkbox, click the DRC button. If there is another DRC button that looks like a DRC with a check mark, but it is for checking the entire design error prior to sending the design out for fabrication. Figure 217 shows the view, zoom and zoom drop down menu and view. The design rule check checks the area within the box while the work. Sometimes it can get away with it can get in the way of doing needed while you're moving the things around. So turn it off for now. To make a board outline, click the obstacle button, which it looks like the move the cursor to the work area with the right click with the mouse, click with the new option. Now pop up menu with the crosshair. Cursor will smaller now. Indicate with the pose for the doing something. Right click on the work again. Select with the properties option for the pop up menu. The edit obstacle dialog box will pop up showing figure 218. Make sure the board outline. Select with the obstacle type of the drop down list for the global layers. Select the end of the obstacle layer. Drop down list. Click OK. Create a board outline similar to the one showing figure 219. Play with the cursor over the origin. Make the drill charts upper left hand corner position 1. Click on the relief left hand button, mouse button. This begin with the first vertex for the border outline. Next, move the cursor to point position 2. The board will sketch the last place. Click them on the cursor cursor. At the position left click to position 2 left click with the release button. Continue with the same manner position 3 and 4. After you play with the final vertex position 4, right click with the bring into the menu box, click finish to complete the board outline. Board outline does not have to be rectangular, but for now it will keep things simple. Or show the edit obstacle name, obstacle type, group weight, height, width, obstacle layer, copper pour rules, clearance Z, order, note with the pin tool for the toggle copper pour seed, to set copper pour seed points, isolate all track seed, only designated object, new attachment from an environment, do not feel beyond obstacles, hatch, pattern, completion attachment, okay, and compartment, placement attachment, okay, and help and cancel. That is your edit obstacle property dialog box. Placing the parts. The components of the initially play with the layout area with the left of the origin typically play in the order of the component number of the board, but may be hard to see what they are, how they are connected. You can move the components around, see them better until they're ready, and play with the board outline. Make sure the component selection tool is selected, and then left click once and release over the component. The component will be attached with the cursor so that if you move it in the desired location, as you move the part around, you will be able to see yellow net list or rat's nest sketch that follows the pad. Click the left mouse button again to play with the component inside of the board outline. Once you have the parts where you want them, you are ready to route the board. Okay, so we've looked at 1, 2, and 3 points, and then it has an origin, placing the board outline. Auto routing the board. To route on board automatically, pull the auto menu down, shown figure 220 with the select auto route board. That will automatically choose the best path of the layers to route with the entire board. Once routing is finished, the information dialog box pops up telling you so. Click OK. Figure 221 shows the example of the routed board. Depending on how you place your parts, layouts may have you the layer different from those shown figure. If the demo version of the layout, there are 4 default layers that are enabled at top, inner 1, inner 2, and bottom. All those together, there are 16 routing layers you can enable and control. You will learn how to control the different layers in Chapter 3 and 9. Manual routing. Chapter 3 and 9 will take an extent of the manual routing trace of the manual routing will be be introduced here. There are 4 manual routing modes. The manual routing selection buttons are located in the tool button bar at location. It looks like these. Respectively, they are the auto path route, shove track, edit segment, and auto edit route modes. And you can see these in the auto on the toolbar, auto route board, DRC button component, halt auto route, and resume routing. Now you see the auto routing. Your board auto routing finished. Trace inner one top, trace on top 2, silk screen, trace bottom layer, origins. First 2 tools, you have some of the auto routing features that are set the way, and you have the manually routing tool traces. They are 2 strictly manual tools, allow direct route control routing process. They can try with the tools you now see with what they do, but don't worry with the messing up of the board. If things get out of hand, you can always start over unrouting the board from the auto menu. You can manually unroute, rip up a trace, or select the trace, then hold down Shift and Control key on the keyboard while left click on the trace. Trace will become a highlighted right click, select one of the unrouting options of the pop-up menu. You can also do as an updated cleanup as discussed below. Alright, cleanup. To perform a cleanup, go to the auto toolbar, tool part of the tool button, or the menu button. Cleanup design figure 222. Next, show the items cleaned up with the cleanup design dialog box. Cleanup checks route problems such as off-grid, acute angles, bad pad X's, overlapping vivas. If you have certain traces you don't want altered during cleanup, any other action, you can lock the traces so that they are protected. So now we've gone to auto and cleanup design. Show the cleanup routing miter 90 degrees, limited accumulated obstacle vertex, share track, share vivas, open optimize pad exits. You can select or clear all override lock tracks. Cleanup database, remove unused pads, footprints, or nets, and then locking traces. To lock a trace, activate one of the manual routing tools, so either the edit segment mode or auto edit route mode. Then select with the trace, hold control button, left clicking the trace, right click and select lock on the pop-up menu, or press L on the keyboard. Forming a design rule check. After you've completed the routing cleaning up of the board, you can check your routes Check for errors. Check for errors from the DRC button, the DRC check button, and the DRC with different from the DRC underline. The online DRC checks the errors as you go and checks only whatever is you're doing at the moment. Project DRC checks the entire board for errors, more discussed in Chapter 3 and 9, how to use the direct design rule check. Post-processing the board design manufacturing. At this stage, layout of the generated design file fully described by the board. The file is optimized for you editing, saving it on your computer, but it is not the part of the many PCB manufacturer fabricating board. The most common type of the file system that you have the PC built manufacturer is the Gerber file style system. Layout with the capability translating a max file structure into a Gerber file system. This is called post-processing the design. Normally you would post-process the design existing location, but for example, it will be much easier to see with the file post-process generators if copy the max to in an empty folder. So save the current max design to a new folder all by itself. To do, select the Save As file drop-down menu. Click Create New Folder, bottom in the Save As dialog box. Enter the name of the folder, hit Enter, then double-click on the new folder, navigate it, and Save button. The next step is to set up the post-processor. Select the post-processing settings from the Options menu, Figure 223. Post-processing spreadsheet will pop up, showing the figure in background, Figure 224. You can use the spreadsheet to enable specific layer the defined Gerber file format and modify the layer setting. Click once for the layer spreading sheets with selecting it, then right-clicking on it and choosing the property of the pop-up menu, or double-click the layer name. From the post-processing set of the dialog box, Figure 224, you can edit the desired properties. The most important thing you can do is ensure that the enable for post-processing box is checked. Layers use the route of the board. If you leave the check box unchecked, the Gerber file will not be generated for that layer. When you are finished setting up the post-processor, click OK and complete the setup process. For example, start a post-processor, click Auto Run Post-Processor for the menu bar as shown Figure 225, layout transmit. It's a max server generator file for each layer if you enable. Post-processing complete with the dialog box pops up telling you create this Gerber design file named GTD extension. Click OK, and immediately another box files up telling you the drill tape I written and throw type hold tab. Click OK again, and finally the text file automatically opens for the notepad. Name listed for the post-processor report, which tells the layers were generated, some information about them. Looks for the words no warnings or errors, which mean that the process is completed properly. Now look at the folders in which you save the copied max file. Depending on the post-processing setting, you should see several new files in addition to the max file. They are Gerber files or digital maps described in Chapter 1. The files that you will send to the board house to have your board manufactured. Alright, so here's the layout domain. You went to Option, you went to Post-Processing Settings. In the Options menu, we've next created a post-processing spreadsheet, post-processing spreadsheet dialog box, enabling the post-processing. We've also went to run the starting the post-processor. Congratulations, you've routed your first PCB. Post-process to the design Orcad layout. Object for the chapter for the demonstration for the basic step of the design circuit schematic laying out. PCB generated the files. Manufacture the PCB file with the same of the process. Start with the capture PCB project using Wizard design circuit Orcad capture. Created layer netlist capture. Save it as an MNL or netlist. Start the layout with a PCB technology, which is a template. We'll save the layout as a max file. Insert your layer layout net listing from capture board. Make a board outline. Position parts out. Auto reroute the board. Post process the boards. Make Gerber file. Manufacture PCB. The next chapter will cover the design flow in greater detail. Learn more about the layout tool set. And this was Chapter 2. We're on to Chapter 3, Project Structures, Layout, and Tool Sets.